Now we're going to look at the forces on a 100 kilogram person spinning around in a centrifuge with a radius of 8.8 meters, traveling at 10 meters per second. Okay, so what we're going to do is we're going to use those formulas we just used. The force is equal to the mass velocity squared over the radius. Okay, the mass of the person is 100 kilograms. Um, and the velocity is 10.0 meters per second. We're going to square that over the radius 8.80 meters. A kilogram meter per second squared is the same as a Newton. Okay, so this is just going to be in newtons. 100 times 100 squared, or times 10 squared, and then we're going to divide by 8.80, and we get 1136, and then that repeats for a while. With significant digits, that'd be 1.14 times 10 to the 123 newtons. And now it said how many times more that would feel compared to, Chris Hatfield was talking about this, compared to gravity. Well, what we would do is we do a ratio. The force due to centripetal forces divided by the force of gravity. Okay, well, the force of gravity is mass times acceleration. So that's 100 kilograms times your acceleration due to gravity is 9.80, right? Because that's the acceleration due to gravity. So that would just be 980. So we're going to compare this to 980. 1136. I'll use this. So how much more is that? We would say this is 1.16 Gs. Um, that's what we say just compared to regular gravity. It'd be 1.16 times that feeling of gravity. Okay, now if we increase to 15 meters per second, let's see what would happen. We're going to use force equals mass velocity squared over radius. Subbing in, we would get 100 times 15.0 meters per second squared, 100 kilograms, and 8.80 meters. So we have a kilogram meter per second squared, which is the same as a Newton, and this would be 2,556.81, repeating for a bit, okay? In significant digits, that'd be 2.56 times 10 to the 1, 2, 3, 10 to the 3 newtons. And now we're going to compare that centripetal force compared to the force of gravity. The force of gravity, we already said from the last one, was 980. So how does this compare to 980? 2557, let's say. So that is about 2.6-ish Gs. So 2.6 times the force of gravity is what this person would feel. You definitely feel pretty uncomfortable. This is getting closer to the acceleration that the astronauts would feel going up into the space shuttle.